Hello everyone and welcome to episode 26. Again, we're going to be carrying on focusing on our enemy object. At the moment it chases the player around, and well, we're still not quite at the point where we're going to make the enemy actually deal damage to the player. That will come soon. What we're going to do is write a attack state for the enemy so that it gets within a certain distance and then performs a little jumping attack. You might think, well, this slime, it actually, it's simple enough. It would kind of work for it to just chase the player like this, right? Just run into them and hit them. And that up to you. You can do it that way if you want, and skip this episode entirely if that's how you want your slimes to behave. But I figure most of you out there will probably want to add more enemy types than just a slime, and maybe have other objects and other enemies that maybe perform a big sword swing, or some kind of like big wind-up attack or something like that when they get within a certain distance that the player can like dodge out of or interrupt, or do something about perform something other than just running into the player, right? So even though what we're going to do today is a little bit specific to the slime, because we're going to write some code that's pretty specific into making it sort of stop performing a little jumping arc and then landing and then going back into the chase stuff. Hopefully it should give you an idea of how to create a unique attack state for a specific enemy. Okay, so in order to get started, we're going to make some changes to our root enemy object, our P enemy. I'm going to go to variable definitions. I'll zoom right in here, scroll to the bottom, where we have enemy aggro radius, which is the radius within which the enemy will start chasing after the player. We're going to have, very similarly, enemy attack radius, which by default will be 16. And basically, depending on the enemy type, but for most of them, when they're chasing the enemy, when they're chasing the player and they get within the enemy attack radius, they're going to go from the chase state to the attack state, okay, which will then allow them to do whatever their particular attack is. Okay, the other thing we're going to do is come into the create event, and we're going to make a wait state as well. Okay, so we'll be coming on to the attack function a little bit later, but we're also going to make a waiting function for an enemy. Pretty useful to have. It's just going to allow us to move from the attack state to the chase state again once we've finished our attack, with a little gap in between. Okay, so rather than just going from attack into chase and then instantly back into attack because you're instantly back in range, just giving us a little bit of breathing space for about 15 frames. And it's just a useful thing to have in general when you get more states and more complex behaviors, to be able to finish one state, wait for a little bit, and then go into another state. And that's what we're going to add the capability to do here. So this script is going to be pretty generic to most enemies. Like, I can't imagine many enemies wanting a unique wait function. So I'm going to write it straight into our P enemy. It's going to be enemy wait. It will be blue because we haven't written the function yet. Don't worry about that. And then in enemy stats up here, in fact, probably not in enemy stats, rather in intrinsic variables up here, because I guess that's what it is. We're going to write state target equals state by default. State previous equals state by default. I'm actually not sure we even use this one, having run through this script a couple of times, but put it in. We might end up using it later in the series. I don't want to second guess myself all the time. Okay, we make plenty of mistakes, but if one of the mistakes we make is putting in a variable we don't end up using, I'm cool with that. Okay, but just so you know, I don't think it's actually that important to this series, but it might be. So we'll get it set up anyway. State wait equals 0, and state wait duration equals 0. Okay, and how this is going to work is fairly self-explanatory. Okay, we're going to have a state that we want to go to after we're finished waiting, how long we have waited for, and how long we're going to wait for. Okay, and we just set those three variables whenever we want to go into the wait state. And then we go in, we wait for that length of time, and then we go to that state. Okay, pretty simple. Let's write the logic for that now. I'm going to go to scripts and add a new function called enemy wait. So that in here now we'll change from blue to yellow. And it's a really simple function. We're going to do if plus state wait greater than or equal to state wait duration. So that's doing two things there. We're adding one to state weight, and then comparing it to state weight duration, see if it's greater than or equal to it. And if it is, state weight goes back to 0, so it's ready for next time, and state goes to whatever we've set state target to be. Okay, next thing I'm going to do is bring in the sprite that we're going to use for attacking. Going to create a new sprite, go to import, into my assets folder. If you're using my assets, it's the one called sslime attack _ strip 6. And it looks a little something like this. It looks exactly like this. It's a little slightly, like, goes into a little squashed frame first, and then it leaps up into the air. We're gonna freeze on this frame for a bit while we're in the air and still moving, and then when we're about to land, we play the last couple of frames and just land. Okay. Make sure the origin is set to bottom center. The name will be sslime attack, and we can close that down. Now let's open up our slime object so we can make some specific changes to the slime. In the create event, we're going to add SPR attack to our list of sprites, which is going to be sslime attack, the one we just added. And in enemy scripts, we're going to write enemy script open square bracket enemy state dot attack close square bracket equals slime attack. Okay, which again is going to be blue because we haven't made that function yet, but that's just ready so that when we do end up in the attack state, it's going to know what function to call. But before we actually make that function, we're first of all going to make some changes to the chase function that allow us to actually get into this state. Okay, so I'm going to middle click on slime chase. You can also open it from the resource tree, obviously. Maximize that. Change our font size a little, and I'm just going to come right to the bottom here, okay? And all we're going to do is simply check if close enough to launch an attack, and then if we are, we're going to go into the attack state and perform the things we need to. Okay, so if instance exists, target, which I'm realizing is a duplicate of this, so this, what I'm about to write here, probably could have gone inside here, but again, I don't like to second guess myself in the tutorial, just suggest things that might be minor improvements if you are feeling confident and want to make them yourself. So if instance exists target, and point distance x, y, target dot x, target dot y, less than or equal to enemy attack radius. So if we're within that 16 pixels that we set up in the P enemy object, or if we've defined that in our child enemy to be lower or higher or whatever it is, if we're within that radius, we're going to set state to equal enemy state dot attack. Then we're going to set sprite index to be SPR attack. So whatever our attack sprite is, whatever our attack state is. Image index is going to be 0. Image speed probably is 1 already, but just to be safe, we're going to set that to 1 so that we're animating at the start of it. And then we also want to adjust our x2 and our y2. That's the position that we're heading towards in this chase state. Because at the moment it'll be the player, but we want to aim just past the player. So if the player is like here in the middle and we're like on this left side of him, we're going to do this little jump arc, and the momentum of that arc would carry us through the player, not just like into the player. Okay, so we don't want to like jump like that into the player. We want to jump as if we're trying to jump past them. So the way we do that is just we're going to use I'll write here a little comment, target 8 pixel past the player, just to remind us. We're just going to use length to x and length to y to add 8 in the direction that we're currently traveling. Okay, so length x2 plus equal length to x 8 dir, and y2 plus equal length to y 8 dir. And that's everything we need to actually get us into our attack state. Now it's just a matter of actually writing that attack function. So I'm going to make a new function called slime attack. And in this function is where we're going to define all the behavior of, actually performing this little jump. Now, this is good. I've called this slime attack for a reason, because this one's going to be pretty specific to the slime. you might be able to use it for other enemies that perform a very similar jumping animation with the same number of frames, but it's pretty hyper-specific to this type of enemy. That doesn't mean we can't learn stuff from it for your specific game and your specific type of enemy. It's more important in this section. The rest of this tutorial has been pretty generic for whatever enemies you want to do, but in this particular section, you want to be focusing on learning how the code I'm going to write works, and less on just sort of, trying to memorize it or anything like that, okay? Because it's going to be very specific to that 6-frame jumping animation we brought in and how that works. Got a lot of magic numbers that we're going to use in here, which are kind of hard to get away from for specifically how we're going to do this, okay? So don't worry that it's a little bit specific. If you pay attention to how it's done and why it works the way it does, you should be able to use the same techniques to make whatever your particular animation is, be it a big swinging attack or anything like that, which will be easier actually, because then an enemy doing a big sword swing probably isn't moving, right? Whereas our slime actually needs to like move as part of this jump, which is going to be a little trickier. But if you learn how it works, you should be able to, as I say, make it work for whatever your enemy is. So how fast to move? First of all, I've commented pretty much every line of this next function just so you can see how it all works. var underscore speed equals enemy speed. Okay, which is, we've built in an enemy speed variable, so we know how fast we want to move on a given frame. Don't move while still getting ready to jump. If image index less than 2, speed equals 0. Okay, so our speed is either going to be whatever our enemy speed is, or it's going to be 0 if we're still on the first few frames of the animation, which is that little like squidge at the beginning. Okay, so we actually stop. We stop chasing the player and we perform a little squidge, and then we're gonna like start moving at the player again. Okay, it just makes it look more realistic. Freeze animation while in mid-air, and also after landing finishes. Okay, so if floor image index equals 3, and we do floor here to make sure we capture it at different times in the animation, because image index is not always an integer depending on your animation speed and your frame rate and so on. It might be like you might be on frame 3.3 or something like that. The way GameMaker decides what frame it's going to show you is by flooring that value. So if it's 3.3, it just becomes 3. If it's 3.8 even, it becomes 3, and so on. It doesn't actually change the frame until you actually move to the entire next integer, okay? So flooring it just removes the decimal and just sends us down to whatever integer we're actually on. So if we floor the image index and we get 3, or floor image, I've done a floor open bracket, image index equals 5, image index equals 0. Now I'll just bring up the sprite again so we can see how this works. Attack. It's 6 frames long, so image index 3 is going to be this fourth frame, which is going to be us like flying through the air. Okay, so once we perform this little jump at the start, once we get to this frame, we're going to stop animating. Okay, the reason we do that is because we don't want to perform the landing too soon, and we don't necessarily know how long the jump is going to be. It might vary, so we just need to hold this frame until we're actually finished like moving in the jump attack. Okay, so we hold this frame, and then we also hold this frame, which is just our landing one, so we don't cycle back around and go back into the jumping animation again if we're just sort of waiting to finish. Okay, so back into the code. How far we have to jump. var underscore distance to go equals point distance x, y, x2, y2, just getting that variable for the next few lines. That's just, how far we are away from wherever we are and wherever we're going, that 8 pixels past the player. Begin landing end of the animation once we're nearly done. If distance to go, I don't know why I put a space there. If distance to go is less than 4, so if we're like 4 pixels from wherever it is we're going to end up, we can begin the landing animation. Okay, so and image index is less than 5, image speed equals 1. Okay, so assuming we haven't already finished the landing animation and we're within 4 pixels of the end, we set our image speed to 1 just to 1.0, I guess, to be specific, to allow us to finish off that animation and perform that little sort of landing bit at the end there. Then we want to move. If distance to go greater than speed. Okay, so if we've got more space to go than we have space that we're planning to move on this frame. If we don't, then we can assume we can just leap straight to that final position, which is what we'll do in an else afterwards. But assuming we've got a little bit of distance to go still, dir equals point direction x, y, x2, y2, just making sure we're facing the right direction. H speed is going to equal length dir x, speed dir, y speed, v speed even, is going to equal length dir y, speed dir. If h speed is not 0, image x scale equals sine h speed. That's just basic movement stuff, right? Just setting h speed and v speed to allow us to move towards our x2 and y2 by this amount, and also setting our image x scale to make sure we're facing the right direction depending on our horizontal velocity. Then commit to move and stop moving if we hit a wall. So if enemy tile collision equals true. Again, this is doing two things. Remember, enemy tile collision commits us to our movement by actually changing our x speed, our x and our y to be whatever they are, plus h speed and v speed. Actually moves us in those directions, but also stops us and sets those speeds to 0 if we're hitting a wall. And it also returns whether or not we're hitting a wall. So by doing an if with that, if that returns true, it means we hit something. Therefore, we're going to give up on trying to reach our final destination because there's no point because we've hit a wall, so we're not going to be able to get any further. So we may as well just say x2 equals x and y2 equals y. Okay, just to stop us in our tracks if we hit a wall. Then else at the bottom here, so this is assuming this is not true, we can just pretty much leap to wherever it is we were going because we're within our movement speed of it anyway, so we were planning to land there and we don't want to overshoot it, so we're just going to leap to the position instead. So x equals x2, y equals y2. If floor image index equals 5, so if we're on that last frame of animation, then state target equals enemy state dot chase. This is what we set up at the beginning, our waiting stuff. State wait duration equals 15. State equals enemy state dot wait. Okay, so we're going to go into the wait state for 15 frames, and then we're going to go back into the chase state. That's assuming we're on the final frame of animation. If we're not, then we're just going to hang out in this position. The function will loop around a couple of times as frames carry on until our animation finishes. So we finish off, we get from here, we go through this frame, land on this frame, and then when we're at this frame and we're at the end of the jump, we can go to the wait state. And then 15 frames later, go back into chasing the player again. That should be everything now. So if I run the game, walk up to our enemy, it chases us, stops, and then, okay, it doesn't work. Whereas it's like going to the first... Okay, I think maybe... You're right. Okay, for some reason I set image index up here when it should be image speed equals 0, not image index equals 0. For some reason, I thought that looked suspicious. It was his first couple of frames, and then we're just going straight back to the beginning. I was like, it should be freezing the animation there, not looping back around. Yeah, that should be image speed equals 0, not image index. Well done if you spotted that ahead of time and were like, Sean, you're going to make another terrible mistake. It happens, but we fixed it quickly at least. So yeah, now the enemy chases afterwards, gets within a few frames, does this little jumping attack. Ooh. just sort of jumps through us at the moment and just sort of tries to land on the other side. And then this will work a lot, but this obviously look a lot better when it actually hits the player and we like, you know, do a little flash and get knocked back and so on. But it's good. And as I say, you can use this kind of thing to create all sorts of different attacks or work with different animations. Obviously, like there's a lot of magic numbers and specific stuff specific to this particular attack animation, but the same ideas can be reused. You've just got to make sure you actually understand what I'm doing here and why, and which bits you want to apply and which bits you don't, and so on. A lot of attacks are way easier than this to do because, as I say, if they don't involve any movement, but it's worth learning how to do ones that do involve movement, little jumping attacks, charge attacks, all sorts of attacks from enemies that might involve them moving in some way, spinning attacks and so on, right? So I thought it was still important to show you how to do something like this. Okay, thanks for watching, guys. In the next part, we'll probably look at getting the slime to actually hit the enemy, hit the player even, or maybe the player hitting the enemy. I might ask my patrons which they'd be more interested in seeing first, and we'll see. Anyway, thanks for watching, guys. Hope you found this one useful, and I'll catch you all next time. A huge thanks, as always, to my amazing Patreon supporters, without whom none of this work would exist. A big thanks in particular, and in no particular order, to the following: Max M, Bowser the Dog, Robert Churches, Dakadondago, Bertie T, Hyungjin, James Siggins, James L. Anderson, Jason, Dark Rider 0318, Hare, Rupinder, Zephyr Flame, Rennie Dam, Samian Yalegaglow, Mark Burgess, Scott Matthews, Leo, Cabbage Pants, Relentless Rex, Figgy, Zach Collett, Joran Pater, Troy Mera, Goose, Alex Schenkel, Justin Adega, Carter Green, Kaiser Ho, Andrew Gilbert, Kimpo, Phil Keane, George Bailey, Vacants, Dalvor, Jordan Hake, and Mr. Oz. Thank you all so much, and thank you, of course, for watching. I'll catch you all next time.